Alright, so my name is Estelle Bacik, and I'm going to be doing my video on differential calculus, which is Unit 7 of SL Math Studies. Okay, so the first thing that we're going to do is defining the terms, so the vocab that is used within this unit frequently. So the first one, the most common thing that we're going to be dealing with all these problems is derivative or derivatives. So this is a way to show the rate of change in a problem. So this is like the amount by which a function is changing at one given point. So it kind of can be defined as the rate of change. A tangent is a straight line or a plane that touches a curve or a curved surface at a point. We're not really going to be dealing with a lot of problems to do with that, like plotting that, but that's also very common in Unit 7. So an example of a tangent would be like this, given on this paper. So this is a tangent. Then the last vocab would be the gradient. This is also known as the slope. This can kind of relate to what a derivative is as well. So it's also known as the rate of change of a function, and it's also known as the slope, as I said before. Okay, so the first example problem is this one. So this is a basic derivative problem. So we have this set up right here. So you have the derivative equation right here. This lays out a function of a times n to the nth, which is the exponent. And then the derivative is shown to be n times a times x to the n minus 1. So it is asking you to bring the exponent down in front of the coefficient and multiply this, or multiply them together and then subtract 1 from the exponent. So let's try this with a simple example. So this can be seen with the function of x squared. So this is the quadratic. So now a coefficient isn't clear to see, but when this occurs, 1 can just be the coefficient because 1 times a number is just that number. So now we have 1 times x squared. Now we are going to put this into the derivative form of the function we saw earlier, so up here. So we brought 2 down right there and multiply it by 1. So this is 2, and then subtract the 1 from 2, so it looks like this. So now we have 2 times x to the first, which is 2x, and then this would be 2x to the first, so that just simply means that it's just going to be 2x. So this would be your answer for the first simple derivative problem. Okay, so the second problem right here is a little bit trickier. This one deals with a little bit longer of derivatives compared to the first one, because the first derivative was a simple function. It just had like the 1x squared to it, so that's just a simple derivative. With this one, example 2, this is more of a common one because there's a bunch of different parts to it. So it's going to be split up into different sections. So this says find g of x. It's the same thing as f of x. It's just like a different letter being used for the derivative. So now we are going to do this first problem. So it says x to the third plus 6x squared plus 12x plus 18. So it's wanting us to find the derivative. And to find the derivative of this function, so with derivatives, we just want to do each of the problems separately, like I said before. So we're going to split it up into each of its parts. So now we're just going to do the same thing we did for the example for each one of these problems or parts, and then we will put it back together in the end to form the answer. So first we have x cubed, and this is very similar to the first example. We just bring down the 3. multiply by the coefficient, being 1 in this case, because there's nothing right there, and then subtract 1 from the exponent we have, so 3x squared is going to be the answer in the end. And then on to the second part, we have the 6x squared, and we just bring the 2 down and multiply by the coefficient of 6 right there, and then we're going to subtract 1 from 2, and that is going to bring us down to be the 6 times 2, so the x to the 1, so that would just be 12x. Next we have 12x, and there is no exponent up there, but similar to when there is an exponent, you would just put a 1. So you can do this with the exponent by just putting 1. So then we would have to bring 1 down to multiply it by the coefficient of 12, and then subtract 1 from the exponent of 1, which would then equal 0. When something is raised to the 0 power, it becomes 1, so that would just leave us just simply with 12. The last part, which is at the end, it's just 18, so there's no x or x squared or anything at the end of it, it's just simply just the number 18. So the last part is 18. Since there's no x value, it can be reduced to be 0, so now we have the derivative equaling 3x squared plus 12x plus 12, because 18 would simply just be 0, so we wouldn't have to put the 18 there in the end. Okay. So this last problem is a little bit trickier. Again, it deals with a bunch of separate parts. It's a little bit longer than the last one, but it's kind of the same thing as the one we just did before. This one's an IB one, so this would have 2 marks. So it would be important to break it up and do it step by step to get each of the marks required. So we're just gonna write down the equation like we did first. So it would be x to the 4th plus 3x squared plus 2x plus x plus 4, and the derivative function right there. So now we're just gonna do what we did before, which is separate it into each parts of the equation. So first we have x to the 4th, and we are just going to set it up as before. So then we get x to the 3rd, simply with the, because you would have to take the derivative or the exponent and minus it by 1, so it would equal x to the 3rd. And we are just gonna do the same thing. We are gonna multiply the exponent by the coefficient and subtract 1 from the exponent. So then we would have 9x squared for this one. Next, for this one, we have 2x squared, and we are just gonna go through the same process again as we did before. So that would be moving the exponent, taking the exponent, minusing it by 1. 2 times 2 is 4, so it'd simply just be, it would be 4x to the 1st, but if it's just 1, you just simply have it just be 4x. And so now we just have the x as before, and we're going to go for the coefficient exponent. So we're going to multiply the exponent by the coefficient being 1, and subtract 1 from the exponent being 1, and so now we have 1 times x to the 0, which is just 1. So that would mean that you would just get the simple number of 1. So then the last part is the 4, which is the same thing as given in the problem before. So when you have just a regular number like this at the end, it's simply like without any x or any exponent or anything, that would mean that it would simply just have to equal 0. So you don't have to put 0 at the end, you would just leave it blank. You wouldn't put it in there into the derivative. So we're just going to put it all together, and you get the derivative of g of x equals x third plus 9x squared plus 4x plus 1, or you could just simply leave it out. You wouldn't have to put the 1 there, because like in the problem before, if it's just a number, you don't need to include it in there. So with separating it and doing this all separately, you would reach the 2 marks given for the IB problem. So then for the IB problem, this one is homework for you guys. So the first question is, a function f has its first derivative given by f of x equals x minus 3 to the 3rd So find the second derivative. So this simply means that you're going to find the derivative of a derivative. So it's kind of the same process as we did in previous problems, but there is like parentheses around there, so you just have to distribute the 3. And then that one's 2 marks. And then for this one, this problem is find f of 3 and then the f of 3 for the derivative, so that is just 1 mark, so just kind of doing the same process as we did before, and then the total for all of these will be 3 marks. So again, this is the homework problem for this one, and then this is the homework problem for this one.